Okay, so in this video we're going to look at the difference between zero order and first order elimination. So if you remember in the first video what we looked at was this idea of first order elimination. So let's just remind ourselves of what that means. So in first order elimination we have a situation where we're modelling the body water as a beaker, and the rate of decrease in concentration, a rate of change in concentration, is proportional to the concentration. So if you want a little bit more on that, go back and have another look at that first video. So if we're talking about the rate of decrease in concentration, that's another way of saying the rate of elimination is proportional to the concentration. So if we were to plot a graph of concentration versus time, we're starting from C0 and we get what looks like exponential decay. What is exponential decay? And if we were to plot the rate of elimination against the concentration, these concentrations are always plasma concentrations, okay? So we're looking at the rate of elimination, that is, say, micrograms per minute. Concentration might be micrograms per litre. So as the concentration in the plasma is 0, there's no rate of elimination, but as the concentration increases, the rate increases. So this is first order elimination. So in this case, a constant proportion or constant fraction is eliminated per unit time. So we said the easiest way to think about that is, for example, the half-life. So you eliminate half of what you had in a specific amount of time, in which case we call this the half-time or half-life. Okay, so it's a constant fraction eliminated per unit time. So zero order is a little bit different. In zero order elimination, what you have instead is the rate of elimination is constant. So the rate of decrease in concentration, now instead of being proportional to concentration, now it's constant. And the model that we think of for that is either an enzyme or some transporter protein. Both of these, so it's an enzyme usually in the liver or the intestinal wall, or it might be a transporter in the tubules in the kidney. Either way, they will show Michaelis-Menten kinetics. So the rate will depend upon the substrate concentration. So as the substrate concentration increases, the rate increases, but then it levels off, because at this point here you've reached saturation. All of the enzymes or all of the transporters are now occupied with the drug, and the rate can no longer increase. So the rate is then a constant. So zero order elimination usually occurs when an enzyme or a transporter protein has become saturated. It can sometimes also occur if the drug breaks down spontaneously. That's relatively rare. most of the time it's due to an enzyme or a transporter being saturated. So we've just said the rate of decrease of concentration is a constant, that's the rate of elimination. So we'd be then looking at the rate of elimination is the same no matter what the concentration is. In practice, actually, what happens is at low concentrations, we're down here. So actually, we're down here on the Michaelis-Menten graph. So actually, the rate can increase as the concentration increases. So at low concentrations, you tend to see first order, and then at high concentrations, the enzyme is saturated, or the transporter is saturated, and the rate of elimination no longer increases. So let's think about what this graph at the top would look like then. So if you're decreasing at a constant rate, a constant amount each time, so we're losing a constant amount rather than a constant fraction. So a constant amount is lost each period of time. So in that case, you get a straight line. And in practice, when the concentration gets back down to this non-saturated concentration, as we were talking about earlier, then you would end up getting back to first order kinetics again. So this is zero order. Okay, that is the zero order. And the other part of it, that is the first order. So also that is the first order. Okay, so that's the difference between first order and zero order elimination.